course. This course contains a number of different modules, and this particular module is about applications and Delta controllers. My name is Greg Holloway, and I will be the instructor leading you through this material. So in this training course, we're going to be talking about applications. So as part of that, what we want to talk about is what Delta controllers are suitable for what applications in the HVAC world, as well as lighting and access, as we'll get to. So inside of the HVAC family, we want to talk about air handlers, VAV boxes, fan coils, heat pumps, rooftops, boilers and chillers, and also stats for wall use, of course, and then lighting and card access. So first we're going to start with the air handler family, and with air handlers there is really a big dividing line. The question is, does the air handler have unitary controllers below it? Like for example a VAV air handler, where you've got a whole bunch of terminal units that are VAV boxes that are going to be networked back to the air handler. So the first question you have to ask yourself is, do I have networked terminal units? If the answer is yes, then we need the air handler controller to be able to support a subnet of terminal units in order to make this whole application work. And so in that scenario, the controllers that are most suitable are the DSC, which stands for Delta System Controller, because it was originally designed to run systems like air handlers, which obviously looks something like this. There are a number of different models inside the DSC family that have different I/O counts for specific needs, basically. But they all have generally this format. The other possible option is the EBCON, and the EBCON is a newer product than the DSC. It has more memory, it has a faster processor, but perhaps the more important aspect is that it's very modular. The EBCON has a brain part of it, and then it has I/O modules, and the I/O modules here allow an awful lot of flexibility, because they can be tailored to the customized to the specific application's needs in terms of how many inputs you need, how many outputs you need, and what style of outputs you need. And this particular little drawing only shows a configuration that has 16 inputs and 16 outputs, but that can be expanded using additional boards to have much more I/O if the air handler were to require it. So it has more flexibility, and it is a newer product. Of course, that flexibility does tend to cost more, so the EBCON is a little bit more expensive than an equivalent DSC for running an air handler, but either one would be an option. Both have Ethernet connections, although we'll get to the networking aspects of all of this in a future presentation. Right now we're just dealing with the mechanical side applications. Now if your air handler is just a single zone unit, constant volume type thing, doesn't have any terminal units, just diffusers in a few rooms, then for that type of application, a DAC-E controller might be a more suitable choice. This is the Delta Application Controller family. That's what the DAC stands for. The -E on the end means it has Ethernet capability, because we often want to be able to talk to air handlers at a quick speed on the network. We want to be able to pull trend log data from them and so forth. So having Ethernet on air handler controllers is generally a good thing. Not specifically required, but it's generally a good thing. So although in terms of the picture, you'll notice that the DSC and the DAC-E look quite similar to each other. The DAC-E is considerably less expensive. The trade-off in that is that the DAC-E cannot support a subnet of terminal units. So this would not be suitable for a VAV air handler. But for air handlers where it is suitable, it's a good option, because just in terms of rough pricing, what we're talking about here is sort of $1 sign for the DAC-E, and $2 signs for the DSC, and then $3 signs for the EBCON solution. So just to give you a guide on sort of rough pricing, basically. Okay, so we were just talking about terminal units, so we're going to move from the air handler down to VAV boxes. Now over the years, because VAV is obviously a high volume type proposition, over the years, Delta has developed a number of different VAV control solutions, and so we have kind of a bewildering array of possible products in our catalog right now for VAV applications. But I want to zero in on the two that make the most sense for projects that are being done at this stage of the game, and not focus on some of the earlier ones that we make that are largely still being made as service replacements for existing projects that use them. So the two products that fall into the VAV application are the DVC, which stands for Delta VAV Controller, and secondly the EZVP, and all of those letters mean IntelliZone, that's the product family. VAV, the P on the end means programmable. I'll explain that in a second, what that actually is about. They are quite similar in that both of them have an integral actuator, as you'll see here in the picture. So both controllers come with an integral actuator. They also have a differential pressure sensor in them that can be connected up to the cross flow in a VAV box to measure the airflow. So in that regard, they're very similar. Also, they both have additional inputs and outputs provided for controlling like reheat valves or fans, that kind of thing that's necessary. So they're both the same in that. The E-Zone product is a newer product than the DVC. The DVC has kind of been our workhorse VAV controller for a lot of years now. Nothing wrong with that. However, there is a significant cost savings with using the E-Zone. So again, if we were to look at cost, again, the E-Zone would be the winner on the cost question, basically. The DVC is a more expensive product. Now, there is, in the programming side of things, the DVC does have some capability that the E-Zone does not have, but this is not typically required for a VAV type application anyway, so it doesn't really much matter. And I mentioned that I was going to say something about the P. This particular VAV controller, the EZV, is available in two variations, the with P and without P. And what the P stands for is programmability. The models that don't have the P have got an algorithm built into them for doing VAV that has a lot of configurable parameters. You can adjust a lot of stuff, but you cannot ultimately change the way the algorithm works. It has its own ideas on how a VAV block should be run. And for more complicated applications or engineers that are demanding and have their own sequence that they need followed, the P option exists, and that opens up programmability in the controller, allowing you to write custom programs to do VAV control your way or to accommodate special needs. So the P version costs a little bit more, but it's incrementally very little. And that opens up the flexibility, and basically the P model is really more comparable to the DVC because the DVC controller is fully programmable. So that's the VAV box market. Like I said, you will find other VAV controllers that we've made over the years that we still have available, but these would be the two primary products that are the go-to products today. Okay, moving on to the next application, fan coil controllers. So we're talking about unitary fan coils here. I've put three different possible solutions up here on the board. The first one is the DAC, Delta Application Controller. Again, this is our workhorse controller that is capable of running a great number of applications because it's fully programmable. And it has enough I/O on it and so forth in order to run a fan coil without any trouble. So that is certainly an option. There are also two products that are in the IntelliZone family. That's the EZFC and the EZ controller. Cosmetically, the two look very similar. If you look at these pictures, you'll see that, hey, they look the same. And that's largely true. They are very similar. But there is significant differences between the two, and that's why I wanted to break this out into two different topics here. The first one, the EZFC, this is the earlier of the two controllers that we introduced, and it at this time only has fixed algorithm capability. It's configurable, but it's not fully programmable, but that is going to change at some point in the not too distant future so that there would be a P option available for this as well. That doesn't currently exist, but it will at some point in the future. Perhaps by the time you're watching this video, it will exist. The EZ controller is available with the P option now. So it does have more flexibility on the programming side if that's required. Eventually they were going to be harmonized in that respect, so it won't stay different forever this way. But the primary difference between the two is that the EZFC runs off 24 volts AC for its own power to power it up. Typical controller power, 24 volt. The EZ controller, however, runs off line voltage that is being used to power up the fan motor. So this will run over quite a range of voltages, but like talking in terms of typical voltages, it'll run off 120 or 240 volt power directly, meaning that it doesn't require a 24-volt transformer at the fan coil to power it up. So the install cost on this should be a little bit lower because there's a little bit less work to do. Both of these products have got on their output side, I'll circle where that is on the controller, although we're not into wiring yet. Both of them have line voltage relays that are capable of running a multi-speed fan and switching the fan motor directly, so there's not interposing relays needed outside the controller to start and stop the fan motor. A nice thing to have. It saves install cost again. So they are the same in that respect. So at this stage of the game, and I haven't talked about pricing, but basically what we've got here is sort of similar to the VAV controllers, where the E-Zone family is somewhat cheaper and the DAC is a bit more expensive. So at this stage of the game, if the line voltage powered EZ controller is a potential fit for your project, then this is probably the go-to controller because it has programming flexibility in the P model, and it has install savings over what a DAC can offer, and the hardware is cheaper to boot. So that's a significant advantage there. And of course, that's why we built the thing. Moving on to heat pumps, you're going to see two controllers that we just saw on the last screen. DAC, Delta Application Controller again, because it has full programmability. It can certainly run a heat pump, has been for years, no problem there. And I carried over the EZ from the other screen. Notice that this does not have FC in it, because the reason for this is that the EZ controller is not strictly for fan coil applications only. It has enough flexibility to be able to do other applications besides that where it's a fit. Obviously, a heat pump is going to have line voltage available at it in order to run the compressor. So in that case, this would be a suitable choice. Now, when we're talking about heat pumps, what I'm really referring to here is the unitary size, single room type heat pump. I'm not talking about the large scale heat pumps that are used with geothermal systems, for example, to exchange heat with the ground. A different controller would be called for those applications. I certainly wouldn't use a DAC to run a building-wide heat pump. That's asking a lot from a DAC. So again, choices for room-size heat pumps, DACs, or EZ controllers, both will do the job. Again, the EZ controller will have a price advantage in terms of the controller hardware versus the DAC. Rooftops. Well, a lot of controllers that we make could conceivably be used for a rooftop. I'm only going to look at the DAC product. Now what I'm talking about with rooftop control here is basically an application where we're going to install the controller inside the rooftop itself, not down on the wall where you might find a straight stick type non-network thermostat controlling the rooftop, more traditional style thing. So this DAC would be mounted inside the rooftop, not down on the wall in the space, of course. And then a thermostat, which we'll get to in later slides here. A thermostat would be installed down in the space and networked up to the DAC in order to find out what the room temperature is, and allow set point adjustment, that kind of thing. So DACs, or the other family, DAC-E, which is basically a DAC with Ethernet capability, would be another suitable choice for a rooftop unit. Has the programming flexibility required and so forth. Now moving off of the smaller scale equipment and onto the larger scale stuff. So we're talking basically with boilers and chillers, we're talking about central plants. So basically central plant equipment, large major mechanical equipment in a building. There are two choices here with the EBCON that we talked about with air handlers probably being the favorite. The reason is because of the I/O customization and expandability. An EBCON can be expanded in terms of I/O modules along the DIN rail there to basically handle any reasonably sized central plant, like all the equipment, pick up everything, because this thing can handle I/O in the hundreds, essentially, in terms of its total capacity. So it's capable of running any reasonable sized central plant. It's not completely over the top. So that would be probably the clear winner. For a smaller unit or a more compartmentalized one where the chillers are in one area of the building and the boilers are in a different area, like basement, penthouse, that kind of thinking, the DSC that we talked about with air handlers would be a suitable choice. The one that we have in the picture here is a model that has 16 inputs and 16 outputs on it. and full programmability and all that. So it certainly has the capacity to run a reasonably sized piece of equipment, but it's not going to run your entire plant. So, with DSCs, you typically would end up installing more than one in order to control all of the equipment that might be there in that mechanical room. But it is a choice. Moving on to stats. So we have two different families of stats right now. Now these stats that I'm going to describe here do not have I/O on them. They don't do local control. These are basically to measure the space temperature and other parameters from a room, allow a display to interact with the occupant in the space, and adjustment of the set point, that kind of thing. So that's what these stats are all about, basically. So the two product families are EZ&S, which is IntelliZone Network Sensor, and DNS, which is Delta Network Sensor, the earlier product that we still make. And so the EZ&S, being the newer one, has got a more modern look to it and so forth. But a couple of primary advantages that the EZ&S has is that the touch areas on here that act as the buttons for doing adjustment, there are a great number of different possible keyboard layouts that you can order. There are a lot of options on the EZ&S product when it comes to ordering time. And one of those is what keys you want to have displayed on the front of it for what functions you want. The one that's on the screen here has got buttons to do like lighting control and blinds control, and that's fine for people who want to do that application. But if you're just doing temperature adjustment, you don't need those buttons. And we have other keypads where basically those are deleted and the temperature increase, decrease, or made larger, that kind of idea. And to do occupancy override and so forth. So there's quite a number of different button layouts available. Another sort of neat plus is that the display here has got a backlight, and the backlight that lights up is multicolor and can change dynamically based on your programming. And that opens up some kind of interesting possible options in a building to have the backlighting and how to change color depending on what the equipment is doing or the state of the building, that kind of thing. In terms of sensors, naturally it has temperature. Kind of goes without saying, if you're going to do space temperature measurement, you better have a temperature sensor on board. So they all have that. Now in terms of other optional sensors you can get with the EZ&S, they are humidity. So these are options on the product. You can get humidity, you can get CO2 for air quality measurement, and you can also get motion sensing, where there's basically a motion sensor on the front of the product, essentially in that kind of area, to detect motion in the space for rooms that are frequently unoccupied, that kind of thing. So the occupancy would track the motion sensor, or turn the lights on, those kind of applications. So that's the EZ&S in a very short version. The older DNS product, which we still make, it has much less button flexibility. There are only 4 buttons on these, and there's basically very little in the way of options for what those buttons are going to look like on their faces. So obviously this product is challenged when trying to control blinds and that kind of thing. There's just not enough buttons to do it properly. The display does have a backlight capability as an option, but it's only an on-off type prospect, and it's just white basically, so there's no fancy color or any of that kind of thing to it. On the sensor side, all of the sensor types that I just covered up here for the EZ&S also apply to the DNS. You can get all of those sensor types on a DNS as well. So it's not compromised for the sensor. So boil it all down, what it amounts to is, if you're doing new construction in a building that's never had Delta in it before, the EZ&S would be the way to go for that. It's a more modern product, it looks better, and so forth. If you have an existing site that has Delta in it already that was using DNS sensors, and you're going to expand that site, it might, for cosmetic reasons, make sense to continue on with the DNS sensors and expand the project using sensors that look the same, because obviously these are in the space and people are going to notice what they look like. So just a thought. Or another thought is perhaps to upsell EZ&Ss as a retrofit to the existing part of the building. So that could go a couple of different ways. Moving out of the HVAC world, we're going to jump over now onto lighting, where we're going to do lighting control in a building. We have 2 products and a number of peripherals in this area. And the 2 products are the DLCP and the DLCG. The DLC stands for Delta Lighting Controller. The letter on the end refers to the style of lighting relay these are designed to work with electrically. The P stands for Panasonic. So this controller is designed to drive Panasonic relays. They're very clever because you can control the relay. So basically there'd be relays that are used to switch the actual lighting circuits on and off. But the relays are very clever because a single wire can be used to both turn the relay on and off and to measure its status to find out what position it's actually in. We also make for this package, we make a lighting package that involves the DLCP controller. We have all of the sheet metal tubs basically for lighting applications that mount up all the relays. We also have a panel shop here at Delta that can make one of these up to your requirements and pre-wire all the low voltage stuff that's inside of the cabinet essentially, so that the install time on site is faster and there's less field work required. And you'd wire in, of course, your low voltage lighting switches you were using, and you'd have the electricians wire in the high voltage that's actually going to the ballast, that kind of thing. So that's how that particular package works. The other controller we make is a DLC-G. This is designed for GE's, General Electric's, RR7 and RR9 relays. These are a really, really old design. Been around at least 50 years, the design of these relays. But they're very common in buildings that have essentially no lighting automation in them. They just have lighting relays, commercial lighting relays. So this controller was made, I would say, primarily for the retrofit market, because if you have an existing GE lighting relay tub that has these relays, instead of tearing it all out, replacing the relays and rewiring everything, this controller can be put inside the GE lighting panel and you control the relays that already exist. So that's the primary use case for it. The DLCP would be probably the better choice for new construction because the relays and the whole package is higher density. You get more relay channels in the same amount of physical space on the wall, and the labor to wire it is lower than the GE solution. So it has some certain advantages to it. But we do have both of those options available. And our peripheral products program that's available in online ordering has additional stuff that you might want, like light photo cells and motion detectors and all that kind of extra stuff, and the low voltage switches that go with these packages, those sort of things. And finally, the last application I'm going to talk about in this presentation is card access. So what we're talking about here is card swipes to open up doors in a building or parking garages, or possibly elevator control where we're controlling what floors the elevator car is allowed to go to. And the way we do that at Delta is a combination of two products. We typically use what's called the EV Manager as the brain of the outfit. So that's this product here in the picture. It acts as the brain of the whole thing. What it contains is basically all the card users that exist and their credential numbers, that kind of thing for cards. And also is making the decisions on what door people are allowed to open and when. All the scheduling type functions, they're all determined in the EV Manager. And that information is conveyed to the second part of the puzzle here over a network. So we've got a little network here, and it runs to the second part, which is this guy called an ADM, which is Access Door Module. What the ADM does is it deals with all of the local I/O that is required. You can see there's a lot of terminals on this controller. That's because this controller is designed to pick up the electrical signals from the card reader, to control the door lock or door strike, to measure whether the door contacts are open or closed, request to exit, all that kind of stuff is wired into the ADM. So typically in a building, what you'll see is the ADMs are located near the physical doors to cut down on the wire runs to the all the component parts of the door. And then the network runs from the ADM, and a whole bunch of ADMs, of course, not just one, back to the EV Manager, and the EV Manager makes the decisions for who's allowed to go where, essentially. That's where all the thinking part is done. So that's the component part. Now, in order to do an actual card access project, there are a lot of other peripheral products needed, like the readers, the door strikes, mag locks, possibly. Those are available, well, on the open market, of course, but they're also available through our peripheral products listing that's in online ordering. We have a lot of parts that would be required for a card access system available in there. If you're not exactly sure where to start looking for stuff like that, that would be a place to go. So those are the parts of the card access system at a sort of very high level overview. And that completes this particular module, which was talking about the applications for Delta controllers and what controller is suitable for what application. Of course, there are additional modules following this. Thank you for watching.